Welcome back to the channel. For this video series, we're going to walk through how to set a static outgoing IP to our Lambda instance. On the left, we have a simple diagram of how this is going to work. We're going to start off with a NAT gateway, route that traffic to an internet gateway, and then send that traffic to the internet, and then reverse the traffic to get the response back. Before we get started with the video, you can help me out a lot by doing a few simple things. Supporting me on either Patreon or GitHub sponsors, subscribing to the channel, liking this video and sharing on platforms you use like Discord, Reddit, etc., starting the GitHub repo, and also following me on GitHub. All these things help me out a lot. I'd really appreciate it. So let's get going. First off, we need to ask ourselves, why do you want to set a static outgoing IP? If you're watching this video, you probably already have an idea of what you're trying to do. Let's go through a few common examples real fast. It's really centered around access control lists. Examples could be FTP servers, web servers, email servers. You want to build a serverless function that accesses these servers, but the person that's hosting the server that's actually running it, they have access control lists, meaning they only allow access from static IPs that you supply them, that they whitelist. In order to have consistent access to these servers from a Lambda function, you have to have a static outgoing IP for your Lambda function, which is what we're going to walk through how to set up in this video series. So the final product is just going to be a simple Lambda function that returns an outgoing IP that is static. We're not going to do anything else. We're not doing anything fancy. Not the point of the video. Just set a static outgoing IP for our Lambda function. You can add the bells and whistles later yourself. So for the outline, this first video we're going through all the components just through simple explanations. In the next video, we're going to set up the outgoing IP manually. And in the final video, we're going to automate it all using Cloudformation, because we're going to find it takes a very long time to build each one of the components necessary and also to tear them down after we're done. So the components we're going to be working with to set the static outgoing IP are all listed here. It seems very daunting when you first see this list, thinking, I don't know any of these, or maybe I only know one or two. Trust me, all the components talk to each other very directly, and I'll explain in intricate detail how each one of these components work without daunting you with a bunch of unnecessary details. So the first one we're going to go through is the Virtual Private Cloud, VPC. What this allows us to do is allows us to launch resources on the AWS management console in an isolated network. We create public-facing subnets which can access the internet. We also create private-facing subnets that cannot be accessed from the internet, where we put our protected resources on AWS, like the databases, the servers, etc. In this case, we're going to put our Lambda function in a private subnet. So let's talk about public and private subnets. There's not too much to talk about here. It's pretty self-explanatory. The one thing you should be aware of with public subnets is they're associated with an AWS availability zone. Say US East 1, East 2, West 1, West 2. You want to pick the location for your Lambda function that's going to be closest to the server that you're trying to access to reduce downtime and latency. The next component we're going to work with is the NAT gateway. This is going to allow instances in our private subnet, which is going to be our Lambda function, to connect to the internet. They're not able to connect to the internet by themselves because they're in a private subnet. The NAT gateway facilitates this. It does not allow inbound connections, meaning that unsolicited inbound connections to our Lambda function or to our NAT gateway are not allowed. We can only initiate connections outbound from our Lambda function and receive a response. And also the elastic IP, which is going to be the static IP, is going to be associated with the NAT gateway, not the Lambda instance directly. Another component is the internet gateway. This is going to allow communication between the VPC and the internet. So the NAT gateway is not directly sending traffic to the internet. It's sending traffic to the internet gateway, which is then sending traffic to the internet. This allows us to access the resources outside of the AWS VPC. So if we go back to the beginning real quick, you see the diagram on the left. Here's our NAT gateway. Prior to the NAT gateway, we have our Lambda instance. It initiates an outbound request. It hits the NAT gateway. The NAT gateway assigns an elastic IP, a static IP, to that request. Then it routes that request to the internet gateway. The internet gateway then sends that request to the internet. And like we just said, the elastic IP is just the static IP address that's reachable from the internet. And like we said before, it's associated with the NAT gateway, not the Lambda instance and not the internet gateway, but the NAT gateway. We also have the route tables. This is going to determine where the network traffic from our subnets or the internet gateway or the NAT gateway is directed. We're going to directly tell them where to send the traffic. So we're going to have two route tables here. One for the NAT gateway, which is going to be for the internal private subnets, and one for the internet gateway, which is going to be for the external public subnets. We also have the Lambda function, the whole crux of this video. You're probably already familiar with Lambda if you're watching this video, but a quick and dirty It's just a serverless option on AWS to allow you to do simple functionality without provisioning a web server, a database, or anything else. And it also happens to auto-scale for traffic, which can be very convenient. And finally, we have this diagram showing how all the components work. We had the previous diagram at the beginning of the video. Here's a much more complex one that covers everything we need to know. We start off in the top left with AWS Cloud. This composes all of our AWS components. We see we have the Internet Gateway in this black box on the right, but it's not contained within the green box. The green box is the VPC, Virtual Private Cloud. The Internet Gateway sits outside the VPC and connects to the Internet outside of the black box. Inside of the VPC, though, we have the public subnet and the private subnet, where the public subnet has the NAT gateway associated with an elastic IP, static IP address. In the private subnet, we have the Lambda function. Like we said before, the Lambda function routes traffic to the NAT gateway. The NAT gateway assigns an elastic static IP address. It routes that traffic to the Internet gateway, which then sends that traffic to the Internet. And on the far right, we have the custom route table. First one at the top is for the public subnet. We're taking all the traffic in the private subnet and sending it locally, and all the remaining traffic we're sending it to the Internet gateway, which will send it to the Internet. And then for the private subnet, we have all the local traffic in the private subnet, we send it locally, while all the remaining traffic we send it to the NAT gateway. So any traffic we're trying to do outbound outside the private subnet, we're going to send it to the NAT gateway to assign elastic IP. Alright, that's it for this video. In the next video, we're going to manually set up the static outgoing IP for the Lambda instance. And following that video, we're going to do it all with Cloudformation. If you have any comments or questions, just leave a comment below and I'll respond as quickly as I can. Thanks for watching and stay tuned for more.